Hello, we're back at it with chapter 14. This is part 4, uh, water resources. We're right in the middle of looking at what we can do to create constant water supply for municipalities and for irrigation purposes. Basically, what we're talking about and what we have been talking about has been in areas where they primarily get their precipitation in the winter months, and then as the summer wears on, if they don't store water, they don't have enough. So we've talked about dams and then the reservoirs that contain the water behind it. Now we're going to look just a little bit at diversion projects. And this would be similar to what we've already talked about, Mono Lake, where the water was diverted out of Mono Lake to use for municipal purposes in LA. So this is not an isolated incident as far as the West goes. Not every town can be located on a river. However, primarily when people settled the area, they did move close to streams, creeks, rivers, so they had an easy access to water. But now, as we have technology, we move the water, and water is usually moved in aqueducts. Also had a picture of that diverting the Colorado River as well. It's very expensive to create aqueducts, moving that water, and controversial in the aspect, how does it affect ecosystems? Once again, please refer to Mono Lake. That is a prime example of diversion of water, as well as the Ariel Sea. Another source that we can tap is the ocean, or even salinated lakes, like the Ariel Sea. Desalination is a method that can be used, and basically that's just take the salt out. Okay. We talked about in class how when water evaporates, it's pure water that evaporates. The salts and minerals are left behind. So in order for, think of the ocean to stay constant at a constant salinity level, then evaporation must condensate, must precipitate in order for that to stay level. Excuse me. Therefore, if we want to use this water, we can use that method, we can use this evaporation, and basically what we do, it's called distilling, and you just simply boil the water. You boil the water, it turns into a vapor, you collect it into the gas, or the vapor travels through a pipe, goes into a holding container where it's then again chilled, and it turns back into liquid water, free of salt. Time consuming. You would have to have a very, very big apparatus in order to use this for a city, but it was some of the first technology that we ever had. Down below, reverse osmosis. This is, I don't know if you've ever seen a pool pump filter, but similar to that, where it's pleated, so it has a lot of surface area, but they're huge, and then the water is forced through, so it's pushed through this, and the filament of the material that's being used for this filter is so small, the weave is so small, that the salts get stuck in it. Well, as you can imagine, those get dirty very quickly and have to be cleaned and replaced. So it's a very expensive method. However, the water that comes out of this is pure. It's very good. There's no taste and odor whatsoever. No color to the water. A lot of times it will pull out anything that colors it as well. So you get very, very clean water from this, but it is an expensive method. So it's a very good thing to conserve our fresh water. Oh, Tampa does have a desalination plant, and it doesn't run or it doesn't provide water for their entire city, but it does increase their output. Water conservation. I told you that 90 to 95% of water used is used by agriculture. So if we can get agriculture to conserve water, and we talked about in class the pivot irrigators and how they would put the hoses on so that they didn't lose water to evaporation. Another way is micro irrigation. Now, this will work with vegetable farms where you have high intensity labor, where you can walk through, pick the crops. It also would work with orchards because the trees are always going to be in the same place. It does not, it's not very cost effective for corn, soybeans, when you're trying to lay pipe in an area where the big tractors run through, because you have to take that pipe up all the time in order to get the tractors through. So for vegetables, fruits, areas like we have out in the Glades and here in Palm Beach County, certainly micro irrigation would work. But for big commercial farms, for the soybeans, the wheat, I'm not sure that that's going to be a cost-effective way or any kind of thing that they even undertake. So, but the piping down to the ground is similar to this. So this really does cut water use up to 75 to 80%. Reducing industrial water, and speaking of industrial, this is one area on the question on the critical thinking you guys tended to miss. And I understand why you put agriculture, and they were looking for an industry, not agriculture, but something that actually manufactures something. So it would have been chemical plants that use a lot of water. So we're looking at ways to reduce this waste, and one of the ways, and the big thing, is for them to continue to recycle their water and use it multiple times. Also to make sure that they're cleaning their water before it goes back into that water system. What can you do? Well, you can turn your water off while you brush your teeth. You can not take a bath to take a shower. And if you want to really save water, and you can get wet in the shower, turn off the water, suds up, turn the water back on, and rinse off. That really saves water. It can be a little cold though. So another way, if you're doing new construction, you can plumb your house so that you utilize gray water. Gray water is the water, say you wash your hands in the sink, and it has soap in it and maybe a little bit of dirt. But that water can then be routed to flush your toilets. Or you use water to take a shower. That water can be routed to flush your toilets. Then the water used to flush the toilet then goes out of the house. Obviously, you don't want to use that again. That would cut down a lot on water use. Also using fixtures that are low flow, and these just simply have little valves inside them like shower heads, and so you don't get as much water at one time. So the little valve prevents massive amounts of water coming out at one time. Also toilets, we're using low flow toilets now. Some of the toilets even have two different buttons to push, number 1 and a number 2. Number 1, you don't need as much water to flush. because it's all liquid. Number two, pushes the solids down. So that's also a way that we can save water, as well as using micro irrigation. Irrigating, really, we don't have to irrigate our lawns in Palm Beach County more than 3 times a week, and utilizing that micro irrigation, and then also utilizing the time zones that have been put out, keeping away from irrigating in the middle of the day so that you have less evaporation. Remember that increases the salinization of your soil. So in the early morning hours or the early evening hours are the best. Early morning is actually the best. And these are the things I just said, so I'll let you write those down fairly quickly. Laws that go with this chapter: the Clean Water Act and the Safe Drinking Water Act. Clean Water Act has to do with water source. So this is your river, your reservoir, lake, and it protects those sources where the drinking water might come from, and your aquifers. Then the Safe Drinking Water Act also overlaps the Clean Water Act, protecting those sources, but this is all about what's pumped into your house. For example, lead in Flint, Michigan. The lead is in the houses. The lead is not in the water source. That's not where the lead's coming from. The lead's actually coming from the pipes in the people's houses. They're old pipes, and they were put together with lead solder. As this water, which has somewhat of a corrosive ability to it, goes through, it picks up the lead. Okay? Because water is a universal solvent. So it picks up the lead, and then the lead is in the water that these children are drinking. Okay? The water source is fine, but the pipe's delivering it. So the Safe Drinking Water Act protects all through that municipal system, so that everybody is responsible, the government is responsible for the water into your tap, so that you are guaranteed good water, at least hopefully. That is the end of chapter 14.